He was also the president of the National Board of Accreditation for 3 years. Earlier, a professor of robotics, control theory, and AI at VJTI. So you can imagine this was today we are talking about AI, but Dr. Mantha, visionary, was doing this about almost, I think, 2 decades back. He currently is the Chancellor of the RB University in Nagpur. He has more than 285 publications in national and international journals, several conferences, besides authoring 3 books. His work at IBM, Poughkeepsie, New York, and Tivoli is also noteworthy. He is the author of NVEQF, now renamed the National Skill Qualification Framework, NSQF, and Regulation for Blended Learning. He was a member Karnataka Skill Development Authority and advisor to Government of Andhra Pradesh. Earlier, he was the Pro Vice Chancellor of SNDT Women's University, the Chancellor of KL University, each of which he served for 3 years. Further, he served as the CEO of Mahapreet Startup Knowledge Center, a Government of Maharashtra company, for 1.5 years. He is also an adjunct professor at NIAS, which I'm sure all of you know, National Institute for Advanced Studies, Bangalore, and chairman of Technical Committee, National Cyber Safety and Security Standards, an IT expert for the Government of Maharashtra. Few things which I would like to share with all of you as a person. About 4 decades back, when engineering admissions were done through a common centralized manner, I have seen Dr. Mantha working at the grassroots level and the manner in which he made the students very comfortable, whether it is allotting the seat, if the name is there in the merit list, how they should go. I shall never forget that, sir. Then later on, his views on e-learning, his views on having the entire administration under one e-governance are worth mentioning. Sir, we all look forward to listening to you and to take some lessons for you from you as to how to be very cool in spite of holding such high positions, which I think can be a great challenge. So with this, welcome, sir, and we are all waiting to listen to you. Thank you so much.
First of all, thank you, Professor Kiran Kulwankar, Professor Usha Mukundan, all the invited guests, my faculty colleagues. First of all, thank you for inviting me to this program and speak to you on, what we call as STEM. I suppose you had a very fruitful time listening to all the experts on the, the various dimensions of STEM education and what it all means. And also thank you for the kind words that you have said. We all try and do a job. And in that process, we also learn several new, new aspects of not only our own life, but also of the society in which we live. Now, this presentation is, as you all must be knowing in the last few days, STEM is science, technology, engineering, and mathematics. Now, that's the simple definition. Anything that you do today has something to do with STEM. Every single application you have that you use in your home or outside your home has STEM built into it. Without mathematics, you can't possibly learn artificial intelligence. Without engineering, you can't build the tools that you require to help you. Technology will build systems, and science is the building block that you need to understand all this. Unfortunately, in our engineering colleges, we look at education in a very one dimensional fashion. We treat science as a subordinate department and things like that. My own understanding is that science is the building block. So without physics, without mathematics, without the basic sciences, there's no engineering. So we need to understand the concepts well and apply them in order to build at the component level, which we call as engineering, or build at a systems level, which we call as technology. So it's very necessary that we understand entire dimension of STEM education. The next, please. So it's STEM is where innovation occurs. Innovation is not where when you design a new device, you don't actually need to design a new or produce a new device or equipment or what. Innovation is anything where you can improve the functionality of what exists or what existed before. And if you can improve the processes, if you can increase and improve any part of the product, that's innovation. And STEM changes the society. Now look at the power of internet or your cell phone. And they have affected our lives in profound ways. In fact, till 2008-9, we didn't have a smartphone. Till 2010, we didn't have WhatsApp, without which we can't possibly live today. We do so much of work. In fact, conduct education sessions as well through WhatsApp. And there's a research study that people learn very well when they are educated with WhatsApp as a medium. So these technologies have all been built from a lot of effort that went into the third industrial revolution, which is the digital electronics. And the digital pace at which the entire digital technology grew was stupendous. Like if you look at the first industrial revolution, it took almost 100 years. The next one took another 100 years. The next one to that took almost 50, 60 years. And look at the technology pace at which it's changing currently. And it's hard. The shelf life for skills today is just about 2-3 years. So that's the way the technology is moving, and what is driving that technology is STEM. And society also changes STEM. Politics, culture, economics, art, music, everything is affected or influenced by STEM. Next, please. So STEM is where the boundaries between science, technology, engineering, and mathematics are permeable. They are mixing. And it asserts that all the four disciplines are also interdependent. There is no science, there is no engineering without science, there is no mathematics without science, things like that. And by blending science, technology, engineering, and mathematics, we create a 21st century learning opportunity and skill development. Now, having said that, there are certain skills that the student needs from all this. Any curriculum that you see today will most definitely, especially in science and engineering, will most certainly see all the four aspects of STEM. Actually, there is one more aspect of STEM. You can also add humanities and art to STEM, which we'll see it somewhere at the end of the presentation. So the skills, like everybody would agree, problem solving, critical analysis, creativity, innovation, these are all the skills that are required. There's one other skill which is not mentioned here, which is cognitive flexibility. The technology has been changing so fast now that one needs to train and retrain and upskill, reskill, things like that. So which means that the work environment keeps changing very fast, and you need to adapt to the changing work environment, adapt to the technology, changes in technology, learn new things, and so on. So therefore, cognitive flexibility, how flexible you are in learning new things and adapting to them, that becomes very important. Next one. So STEM is used in everyday life. If you look at this, slide from the right, you have a traditional way of learning. There's a method, you memorize, you recite, read, practice, and then you grade. That's the traditional way of learning. In the STEM way of learning, you have observation, then you have a hypothesis, then you analyze the hypothesis by various methods, and then you question why, and more importantly, why not. And then you conduct experiments, and then you draw conclusions. Now, that's the STEM way of learning. Now, this is extremely important in the way we change our pedagogies in our classrooms. So every faculty, every teacher must understand that we need to move out from the traditional way of teaching, learning, to more accommodative way of learning, collaborative way of learning between various aspects of STEM education. Next. So there is a role of STEM in various activities of what we do, and I'll briefly go through each one of them. In research and development, STEM fields fuel R&D, obviously, leading to groundbreaking technologies and solutions. Later on, we'll see some examples as well. In biotechnology, have revolutionized healthcare. Many of you must be knowing during COVID times, there has been so much of research which moved around STEM as a concept. Then you have interdisciplinary collaboration. Innovation often arises from collaboration. Like I said in the beginning, this world today is one of collaboration. Without collaborating, nothing happens. You can't be a silo. You may be a very good physics person, physics teacher, physics, one who understands physics, but you're not interacting with mathematics. There's nothing that you can do. And similarly with other disciplines. So therefore, innovation often comes from STEM disciplines. You need to blend engineering, computer science, and biology to create new products, processes, and so on. Then entrepreneurship, the STEM graduates drive startups. Drone, which you see offer almost everything today, is a product out of MIT labs. And what they do is they create concepts, they give ideas, they generate ideas, ideation happens. And then there are a variety of tools available to very fertile minds to think and do whatever they feel like. And so they apply principles of physics, then physics to engineering, engineering to technology, and so on. So that's how the drone technology was developed. And in fact, MIT allows fab lab, what is called as fabrication labs, or fab labs for short. And I believe if you really want to do something in STEM education, apply the 4 fundamentals, then you also need to subscribe to Fab Labs of MIT. And then your students would have another dimension of, getting into a lot of ideation, getting ideas for new startups, and so on. So it also has a role in economy, in improving economy. So STEM industries are among the fastest growing sectors, and they give you high skilled jobs. In fact, on jobs, I would just want to tell you that today the entry level jobs, essentially because of the automation, AI in particular, intelligent agents in particular, the entry level jobs are vanishing. And in that place, what replaces it is high level skill jobs. So which means that a student who passes out from a college, maybe graduation or whatever, he will need to upskill himself much more than what the graduate program could give him, because those higher level skills are required to even get into an entry level job today. Innovations in STEM also lead to more efficient processes in various industries, enhancing productivity, reducing costs, and so on. Global competitiveness is something very important. STEM education and research gives a pathway to global markets, and therefore it influences the economy of a country. Next. Now, STEM also helps in problem solving. Now, how does that happen? STEM professionals, which means professionals who use all those four elements, they tackle pressing issues like climate change, public health crisis. In fact, during COVID times, you needed every one of them to contribute. Somebody to make a new device, someone who was needed to help out in instrumentation, someone to create new concepts, new formulations, things like that. So unless every one of them comes together, you can't really solve complex problems. Then from renewable energy technologies to advanced materials, STEM provides tools and methodologies to address several challenges. So each one of these is a research area, and a lot of, in fact, an hour can be spoken on each one of these aspects, but that's not the requirement for today. Next. So learning by doing. This is what STEM is all about. STEM teaches you to actually do it. Don't just ideate, and don't, have ideas which cannot be translated. It's very necessary to learn by doing. Next. So there are certain current trends about STEM which we need to understand. AI and machine learning are obviously there everywhere. I am sure many of you must have used ChatGPT, things like that. And something that is amazing is the generative AI, and where large-scale learning language models help out in collating data, bringing out intelligent patterns out of that. So that's a very big area where STEM means, it makes a very big difference. Now, AI is not new. Many of you may be aware that the first chatbot in AI, ChatGPT also is a chatbot. However, the first chatbot came in 1963. And this is by Joseph Rosenbaum, who was an MIT professor, who created a conversational style program, in deciphering natural language. And it was called ELIZA. And that was a program which was the precursor to many such programs, which later on, with a lot more of STEM coming in, was possible to deliver. So machine learning, again, something that you can use for predicting. There are several algorithms which we need to understand. But in order to understand AI, machine learning, or any subject around that idea, will require Python, not Python, it requires statistics, it requires probability, and it requires linear algebra. Now, without that, you cannot really get into a lot of AI, lot of machine learning, so on. And Python essentially uses the concepts that you study in mathematics, in probability, in statistics, so on. So that's where the connect happens. So I have seen several curriculum in the universities where they start teaching, even as early as first semester, they start teaching Python, which is bad in concept. The natural flow should get them a base in mathematics, build a base in mathematics, build a base in probability, in statistics, and things like that. So that's the way. So the people who develop curriculum also need to understand where the building blocks lie and whether there are prerequisites that are fulfilled when we move into higher order skills. So healthcare, obviously, your predictive analysis, your medical imaging, personalized medicine, and drug discovery, all of them are complete STEM projects. So AI algorithms analyze patient data to predict disease outbreaks, patient outcomes, hospital readmissions, and so on. So there is a massive input of requirement of understanding physics, understanding biology, understanding mathematics, so on. Obviously, medical imaging, they allow you to interpret. There are several research projects again happening in the healthcare sector where MRI scans are being, analyzed to predict the outbreak of a disease or the presence of a disease in a certain human being, and so on. Personalized medicine, obviously, AI, a medicine is something like tailor-made medicine. So based on individual genetic profiles, so you do a genetic mapping, figure out what specific medicine can help you. So now, obviously, the drug discovery, which was extremely useful during the COVID times by predicting molecular behavior and optimizing chemical compounds. Next. Yes. There are certain trends, again, like I said, in different sectors. So this is a sector in education, and STEM has helped in adaptive learning, automated grading, and predictive analytics for retention. Let's look at adaptive learning. There is a open loop control process, there's a closed loop control process, and there's an adaptive loop control process. The open loop process says, I deliver something and I assume that you have understood what I have delivered. There is no feedback. So that's an open process. In a closed loop process, I deliver, I have some outcomes in my delivery, and I can measure those outcomes and figure out where the gap exists, and then correct the process right from the beginning. So that becomes a closed process. And in an adaptive process, what I do is, in an adaptive process, since there are multiple elements that define a system, a complete system, there could be an error in each of those components in the system. So therefore, I correct the component level requirement, which means that I keep correcting as I making mistakes. So which means that I converge to the right solution much faster than a closed system. So therefore, adaptive learning methodologies are used in almost every single platform today, LMS platform that you may be aware of. You must be using Campus, you may be using Coursera or whatever. They all use adaptive learning techniques. Automated grading, obviously, slow learners, fast learners, all that difference can be figured out by monitoring the progress of a student through various steps. So automated grading, and then predictive analytics is where do I need to interfere in order to make the child learn better. So therefore, these are all applications, but then these applications were there is a psycho analysis also that is required. The psychological analysis, the psychometric test, all those are built into the application, which means that again we are moving into the basics, and then basics of STEM, basics of physics, basics of psychology, and things like that. In finance, we have fraud detection, algorithmic trading, credit scoring, risk management. Algorithmic trading is extremely important in finance today, and there are multiple jobs available, but then the skill level that is required at the entry level is extremely high. Artificial intelligence systems, they analyze market trends and execute trades at optimal times, often faster than human traders. So this is an extremely upcoming area within the financial markets. And in order to, I'm sure none of the colleges, whether it's finance program or commerce program or whatever, algorithmic trading is actually taught. I wish the curriculum undergoes changes. They introduce this as value-added courses or whatever, change the curriculum, because they are the building blocks that you require for meaningful employment tomorrow. Risk management is again extremely important, as you understand. Mitigate risks by analyzing historical data and predicting potential market shifts. Not only in finance, but even in project management. When you undertake a large project, what are the risks involved? How does one? So we looked at the trends in education, trends in finance. We'll go ahead. So there are also trends in manufacturing and agriculture. Now there is predictive maintenance that is required. Traditionally, we all know one is preventive maintenance, and then the other is breakdown maintenance. We never really worried about predicting maintenance. Is it possible to figure out when the machine would actually fail or which component would actually fail, and so on? That comes into the area of Industry 4.0. There are multiple technologies that drive Industry 4.0, and they are all STEM-based technologies. So predictive maintenance is an application of some of those features that we look at in manufacturing, which of course requires a lot of sensors. It requires IoT technology. It requires a lot of algorithms, which machine learning algorithms, and so on. Quality control is another. Supply chain optimization. Any supply chain will have multiple steps, and can we optimize that and create a revenue model which actually looks at the return on investments and so on. Within agriculture, you have precision farming, you have crop health monitoring, pest and disease prediction. Just one I'll go through here. Again, precision farming, artificial intelligence comes in, data from sensors. Any Industry 4.0 today cannot work without sensors. Human intelligence is because of sensors. We have sense of touch, sense of vision, sense of, 5 major senses. And that is what gets us the information to make decisions. So there are multiple other things. There are many more sensors as well. There are vestibular sensors and so on. Your ability to stand straight, your ability to run, and so on. These are all due to sensors. Now, in a physical system as well, you need multiple sensors to measure various operant, and the data that comes out from those sensors, you use to make decisions. So the data will be that will be a very large data coming as it is on almost online, real time, and therefore that data helps you in making decisions, provided you can analyze that data, which means you get into the big data problem and then take meaningful decisions. So whether it is planting, watering, harvesting, increasing crop yields, while minimizing, resource uses and so on. So everything concerns STEM. Next. In transportation, you have autonomous vehicles, you have driverless cars, self-driving cars which are powered by artificial intelligence, which means you take the historical data, the traffic pattern along a certain route, and then use sensors, gather real-time data, and then analyze them to move through safely and efficiently. Traffic management, of course, every single traffic signal that you must have seen while driving on, even on our roads, there is a signal that keeps changing, after a certain time, and so on. Now, many of these systems at important junctions are all driven by SCADA, and SCADA is an extremely important application of STEM. So you also do route optimization. In fact, when you open your maps on Google, you get somebody telling you, go right, go left, so many meters ahead, there is traffic, things like that. This is all from the GPS data. They connect to the satellites, get the real-time data, and use some algorithms to deliver information in certain way. Now, all this is possible. The reason is STEM. In retail, you have personalized recommendation. Any time you search for something on Google, the next time it will tell you the related things. So, of course, there is a lot of debate on privacy of data privacy and things like that, but we don't get into that now. Inventory management, chatbots, customer service, everything is done through AI-driven tools. Next. Yeah. The simple question is, did you know that for every 2 available STEM jobs, there is only 1 qualified professional available? So which means that there is a lot of work to do from the university side, from the colleges side. I don't say that every skill must be given through STEM, through the university, but the tools must be made available to the students. Next. So technicians, engineers, scientists, professionals in the STEM fields, you have science on one side, engineering on the third corner is technology, and the binding force is mathematics. So without this, there is no engineering. Without this, there is no technology. Without science, there is nothing. So that's what this slide tells you, that science seeks to explain the complexity. It gives postulations. It treats how the subject must be, related, and so on. Engineering applies those basic principles, those postulations, builds components. Technology uses all the innovative tools and builds a system, and together, and every one of that aspect has some mathematics in it. Next. So let's look at some applications of STEM. In biotechnology, you have genetic engineering, monoclonal antibodies, vaccine development, and diagnostic tools. All this in some way were very, very active during the COVID times. You have gene editing technology that allows researchers to modify DNA of living organisms. Some of you in your colleges must be doing some research on this. It needs mathematics, it needs all those 4 elements. Then we have agriculture, genetically modified organisms. You have biofortification, plant tissue culture, biopesticides, and biofertilizers. All of them are STEM controlled. So just one of them, biotechnology develops crops that are resistant to pests, diseases, and environmental stress, enhancing food security and agricultural sustainability. Many of the countries, especially Israel, especially Germany, and a lot of states within US are into genetically modified organisms. Several universities in the United States. Next, please. Next, please. Yeah. We have some applications in renewable energies, photovoltaic cells, the entire EV technology, electric vehicle technology, runs on STEM principles, the photovoltaic cells, solar panels, enhancing their efficiency through materials, science, engineering, solar thermal systems, concentrated solar power, which supplies ultimately to the smart grids. Now, all that is a part of STEM. In fact, anything that you do today is a part of STEM education or STEM application. In terms of wind energy, you have turbine design, you have again predictive maintenance, wind farm optimization, and so on. All these are great examples in different sectors. Next, please. So these are the 10 technologies which are driving STEM today. And incidentally, these 10 technologies also drive Industry 4.0. And there are many more, in fact, one of the concept in Industry 4.0, we have been talking so much about predictive maintenance. It's the machine itself knowing whether it needs lube oil, whether the lube oil has gone down its limit, and if it needs, it generates an alert. It also triggers the lube oil dispenser, and then it fills in. So the entire operation is automated. Now, what it does to the employment market is a different story. We can do that some other time. So it doesn't mean that it destroys jobs. What it means is it changes the contours of jobs. The jobs that are available today may not be available tomorrow. So that's where you need cognitive flexibility in understanding, fitting into different technology scenarios, and so on. Now, along with these 10 technologies, there are many other IT-related technologies that are useful in Industry 4.0. For example, blockchain, your DevOps, your 5G technologies like that. Next. So going back, you have hydropower, you have you have thermal power, you have hydropower, you have wind power, you have solar power, renewable power, non-renewable power. But everywhere you need the basics of physics, chemistry. In fact, the BSc in chemistry, the curriculum I've been seeing, and personally, I thought a lot of changes need to happen there. Today, we don't teach battery technology. The future of the transportation is electric vehicle. And one of the most important feature for an electric vehicle is the battery. In fact, 55%, 60% of the weight of a vehicle is just the battery in an electric vehicle. So a lot of research is required into that. In fact, the research is also required into recharging technology, charging technology. All that is a chemistry application. So we need to re-look at our curriculum and modify that. Then environmental impact studies, pumped storage systems, biomass energy, biofuel production, waste to energy technologies, life cycle analysis of these technologies. All that requires STEM, are STEM applications. Next. So geothermal energy is another very, very important energy source. So modeling, reservoir modeling, geologists and engineers model underground reservoirs to optimize energy extraction from geothermal sources, especially when the non-renewable sources are depleting fast. We need to look at other sources of energy. Then you have heat pump technology. This is a very traditional, very old technology which we use with the tools available today to design geothermal heat pumps that transfer heat between buildings and the ground. Is it possible to optimize the energy requirement of a building? These days we are building or we are constructing new buildings where there is a lot of energy requirement. And if you know 40% of energy is required only in driving those AC air conditioning systems. So unless we optimize on energy, the energy requirement of a building itself would cause a lot of problem. And when you are talking of blockchain technology, the amount of energy that you require to drive the computer systems would actually go through the roof. So therefore, it's very necessary that we understand technology, we understand the energy requirements, and we build auxiliary systems in addition to the main systems for energy. So battery technology, obviously, I said advances in chemistry, materials, science, and so on. It's very necessary for determining the life of battery and how you charge and how many times can you charge. And if after every charge, how much does the efficiency go down? These are all chemistry related problems. The next, please. So grid storage solutions. You have multiple sources of energy now. Like you have seen, you have thermal energy, you have hydro energy, you have all you have solar energy, solar power, and wind energy, and so on. So if I hypothetically in a system, if I have all these energies, how do I optimize? Which one is more suitable at what time? What are my load requirements? What machines or what equipment requires what kind of load, and which energy I can shift where. So these are very involved studies in order to optimize the energy requirements. And then, of course, hydrogen production. There are various ways of producing hydrogen, and STEM applications in electrolysis convert renewable energy into hydrogen, a clean fuel for transportation and power generation. Things are not as simple as 2-3 lines that I have written here. Hydrogen generation is a problem. Hydrogen storage is a problem. And hydrogen release in a very controlled fashion to power equipment is another problem. So, but all of them get their basis in physics, chemistry, mathematics, then engineering, then technology, and so on. Of course, smart grids have energy management systems, demand response technologies, and so on. Next, please. Robotics and automation is an extremely important part of STEM application. Industrial robots is one aspect where we use, for example, if you have had a chance of seeing Maruti factory in Gurgaon, everything is operated by robots. Kawasaki in Japan, which produces again 2-wheelers, 4-wheelers, and so on, that company uses a robot even to operate its showroom. So there are applications which are extremely useful in industrial robotics. There is robotics required in remote handling applications in nuclear reactors and so on, where the spent fuel is radioactive. So you need to remove the spent fuel, add new fuel. It's all radioactive zone. So therefore, you have remotely operated robots. Someone sits outside at a 10-kilometer distance and operates a robot which is sitting inside the reactor. So these are all these things require a lot of real-time calculations, and one needs to estimate the transmission losses, account for them, then work out the dynamics problems, and so on. Inertia is all of you understand, where when you build real-time systems, the inertia plays a very important role. And you need to understand that in a machine, I need to build all those concepts. So you have collaborative robots. In health sector, you have surgical robots, you have telepresence robots, you have rehabilitation, you have active robots, you have passive robots. In physiotherapy, you have passive robots, and so on. Next, please. So these are some of the technologies which again use STEM, artificial intelligence, Any technology, then Internet of Things. Internet of Things is like you need internet, obviously, and thing is a sensor. Anything, any communicating device on the internet is a thing. So your laptop is a thing, your pen drive is a thing, your camera is a thing. Anything that is communicating is a thing. So Internet of Things and the network of those things. How do you analyze? How do you work around them? Computer security, robotics, augmented reality, which is again useful in education, different pedagogies, and so on. Next, please. So you have automated harvesting, you have drones for crop monitoring, you have precision agriculture, you have autonomous vehicles, drones for delivery, robotic logistics. Again, very, very important areas, subtopics in robotics and automation. Incidentally, robotics comes out from a word called robota. Robota is in Czech Republic word in the Czech Republic language that they use. Robota is a word which means forced labor. So robots are like slaves, forced labor. So that's where the concept comes in. And then Isaac Asimov and those people created a fantastic world around robots, and they coined word called robotics. So that is how this develops. Next, please. So you have space exploration, you have robotic probes and rovers. All of you must have seen Sunitha Williams is stuck outside above the stratosphere. So how do we get her back? So there are a lot of robotic tools available. There are platforms which are moving in space, so on. So all that needs real-time calculations, which even a microsecond error would probably push the vehicle into empty space. So therefore, it's very necessary that the algorithms are correct, the algorithms are executed correct, the transmission losses are filtered out, and so on. So you have consumer robotics, your home automation, your assistive robots, social. Alexa, you all must have heard, is a chatbot, is an AI application, and many of you must be using it even now. Next, please. Any university website you go, there are chatbots which come in, they'll start talking to you. What do you need? All those are AI applications. Your KYC is an AI is a robotic process application, process automation application. For example, when you want to open a new account, you keep getting messages on your mobile. You get OTPs, you get you are asked to do something. They're all robotic process automation applications, and therefore these are technologies which are driving the world today, and they all have basis in STEM. You also have robotic kits which are available in the market. You can build different systems for yourself. Your colleges, the students, they must be encouraged to do this. Simulation and modeling, this is a huge topic. Nothing in 2 lines that you can do here. There is a lot of kinematics that comes in. There's statics, there is kinematics, there is dynamics. So therefore, there are a lot of mathematics that comes into it. All of you must have studied, scalars, vectors, and so on. The simulation and modeling is entirely depends on tensor analysis. And therefore, mathematics is a very integral part of learning robotics, automation, and so on. Next, please. These are some, competitions where your students must participate in robotics. There are a number of competitions in Japan, in Singapore, in China. The students must be encouraged to participate in them so that they learn to do. They learn by doing. Next. So there are some real world applications. Telemedicine, which is very happening today. Remote consultations, monitoring chronic conditions. Your wearable device, it also monitors you in the morning when you keep walking. It measures your number of steps, it measures your blood pressure, it measures your pulse rate, and so on. So these are all, monitoring their sensor. Basically, they're sensors. So they gather data through different principles. Every sensor will have, is also called a transducer, and the transducer will have a transduction element, which is again some change in resistance. That element resistance may change, capacitance may change, the inductance may change, the impedance may change, which means that I should be able to calibrate the change in terms of the measurement that I am interested in. So yeah, monitoring chronic conditions is again something very, very doable. Health tracking devices, I already talked about, wearables, smartwatches, medical wearable devices, glucose monitors, provide real-time data for diabetic patients, and so on. Next. So this is some representation of various things that come into the domain of STEM education. Next. So online learning platform, MOOCs is a STEM application. Like honestly speaking, anything that you're doing today is a STEM application. So then you have coding boot camps, people, those hackathons which people, various organizations have today. You should encourage your students to do all that. So they get into the practice of learning by doing. So learning mathematics, learning can be fun. In fact, we teach mathematics without any understanding what the various concepts are. For as a small example, we teach differentiation, we teach integration, but very rarely we tell people what actually differentiation does, or what actually integration means. What is area under curve? How is volume measured? Things like that. So these are at conceptual level, and if we can do that, mathematics or learning mathematics also can be very interesting. So I spoke about smart agriculture, climate modeling. Next, please. So these are some of the things that I need. Like I said in the beginning, problem solving, creativity, critical thinking, communication, collaboration, data processing and analysis, computing, and IT. Without this, people cannot do anything today, whether at home or outside. Next, please. They are all careers in STEM. So this is something more that I'm showing here. Project-based learning, which you should adopt in classrooms. There are. It starts out with students' voice and choice, feedback, presenting a solution, driving question, need to know, inquiry, and innovation. In fact, in a classroom, we should encourage to people to ask why, not only why, but also why not. There is nothing like learning because someone is telling you. You should be able to analyze that by asking questions. Next, please. So personalized learning versus differentiated learning is a part of education within the STEM sector. Differentiated learning is how different people learn at different pace, their different skills, and so on. So can we really figure out how we package our teaching part to suit different learning styles? And all this is built in LMS platforms today. Next, please. So what are the challenges in STEM? Workforce shortages is a big challenge. We do not have, there are several new areas that are coming up, but the people to drive those systems are still difficult to find. So there's a talent gap. There are retention issues. Many skilled workers, they leave for better opportunities. So your day-to-day work gets affected because you do not have sufficient number of trained personnel. Diversity and inclusion, there is an underrepresentation. Women are in minority in STEM education. There is a a large percentage of men in the area, and it's very necessary that women are encouraged to get into physics, chemistry, mathematics, engineering, technology, and so on. And there are barriers to entry, socio-economic factors, educational disparities, cultural biases. These are all the challenges. Next, please. When I said women representation, I have two slides here, which will tell you actually how women are faring in STEM education. I have given on the horizontal scale different, disciplines and how the enrollment is happening. So there's a male participation and a female participation. In technology, if you see it, 71% are male, remaining is, almost. So therefore, what needs to be done is more opportunities and more encouragement for women to come into the field is required. Next, please. This is one more which tells you percentage share of female students in different degree programs. This again is very interesting. It tells you what one should do to promote, STEM education within the female population. Next, please. So rapid technological change, like I said, there is a shelf life for skills today. Unlike our times, we used to get some skills during our graduation, and that used to stand good till we retire, or we would have retired. Today, the technology is changing very fast, so therefore the skills that we acquire also has a lifetime. So today's shelf life is just about 3 years. So which means that you have to retrain yourself after 3 years because the technology would have changed by that time. Then keeping up with advances, skills, obsolescence. My skills are becoming obsolescent because of my technology changing so fast. Funding and resource constraints, research funding, educational resources, they're all they're limited in supply. Next, please. So public perception and misunderstanding. People think STEM is some, technology which is difficult to figure out. But then it actually is physics, mathematics. If one has to be good in some core sector, then they can progress well in the STEM applications. Interdisciplinary collaboration. In fact, in our institutions, whether it's engineering, science, arts, commerce, we hardly collaborate. The chemistry teacher, have you ever seen a chemistry teacher collaborating with a physics teacher to produce some new paper, or maybe, a mathematics teacher collaborating with a physics teacher, or an electronics engineer collaborating with a mechanical engineer? Not seen at all. So therefore, these things have to change if STEM has to pick up. Communication barriers, effective collaboration requires strong communication skills. And then ethical and social implications are there. Ethical dilemmas are there. Advances in AI and data privacy issues, which I spoke to you, there are ethical issues. This again will take 1 hour to really understand what ethical issues are there within AI. There is also a societal impact. There are unforeseen social consequences resulting from STEM professionals. For example, we all know the chlorofluorescent chemicals which were used earlier as refrigerants. They used to deplete the ozone layer, and so therefore the Montreal project came about. People said we need to change this things which are depleting the ozone layer and so on. So there is a societal impact to everything that you do. There is also, in fact, one interesting part you may be knowing, there is what is called as triple P bottom line. Okay, the first P is about profit. So when the industry came about in the beginning, when industry started coming up, the only consideration was how to make profit. So they optimized everything in order to maximize the profit. So that was the first P. Later on, people realized that the profit is not important. Profits will happen provided we take care of the people who create those profits. So therefore, you had labor, scenarios changing to introduce incentives to, to take care of the people, their housing, their other requirements. So people centric activities started happening. That's the second P. So while this has been happening, there is a lot of technology that has changed. And therefore, now the question is, all this that we are using to produce comes from the earth. So someday this is going to vanish. Then what will happen to our earth? So the third P is planet. So now everything, every manufacturing activity, everything that we do must look at sustainability of the earth, of the planet. So that's the third P. So together it becomes triple P, bottom line. So interdisciplinary collaboration, ethical, social implications, they're all there. Next, please. So what is the future? Future obviously is AI and ML, because they will, in some form or the other, they'll keep coming back. So enhanced decision making, automation, personalized medicine in healthcare, telehealth expansion will happen. Next. Renewable energy will grow much more. Smart grids is already happening. Energy storage solutions, batteries, new materials in batteries, how to store more energy in less space. Like I said, an electric vehicle, almost 55% of the weight of that electric vehicle is the battery. So therefore, can I reduce that? If I reduce that, my efficiency will increase. So there'll be more energy for, for the raw material that I spend. So energy storage solutions, robotics, collaborative robots or cobots, collaborative robots, and autonomous systems become important in future. Next, please. Data science, big data, privacy securities, predictive analysis, circular economy, innovations in materials. There are a lot of new materials are being found, are being developed. Nano coated materials are being developed with different properties, with diverse properties as well. And they will lead to sustainable production methods, waste reduction, and the development of biodegradable materials, and so on. So next is smart agriculture. That's another area. Next, please. Education and workforce development. Obviously, this has to change. Skills development, new skills will be required. Convergence of fields, bioinformatics, neuroengineering, environmental science, they are all coming together. So there is nothing like a single area specialization that will help. You need to understand many other related fields in order to become a good STEM person. Next, please. So future potential is quantum computing. When quantum computing comes in, there's a lot of change that will happen. 100 times or even 1,000 times much faster computers will be there, and therefore all your algorithms will be solved much faster. So therefore the entire IT space will change. There is a lot of research within the complex simulations which are required in genetic modeling and so on. Next, please. Optimization in engineering and physics and cosmology, AI and machine learning, these are all the areas that will grow in future. Next, please. Some of the future technology, if you read this, you will realize what is probably the direction in which we are moving. The future of work in industry, that figure tells you how the industries will transform. The fastest path to net zero. Net zero is a concept which again you will need to understand. Path to net zero buildings and corporate progress towards net zero. Net zero is a huge factor which will be required in future. Next, please. These are some more downtime free future in industry. There is no downtime, which means nothing fails. That's the future. So, role of home energy efficiency, AI disruption, challenges in guidance for data center design. Data centers are guzzlers of power and energy. So, can we design something which does so much of work, but with lesser energy consumed? Maybe quantum computing or the behavior of an atom at the subatomic level. These are all required. And again, we come back into basics of physics, basics of chemistry. Next, please. Cryptography and cybersecurity are, offshoots of all that we are talking about. Quantum networking and communication. Quantum will grow in a quantum fashion. The principles of superposition, entanglement, these are all extremely complex phenomena which have their basis in physics. So unless we understand the concepts in physics, we will not understand quantum systems. Next, please. Medicine and healthcare, electronics and computing, nanoelectronics, flexible electronics. You already have flexible folding screens, in your mobile. So that's something that will grow to massive proportions. Next, please. Energy and environment, nanomaterials for energy storage. Can I store large amount of energy using nanomaterials? Environmental remediation, clean energy production, nanocomposites for stronger materials. Can I reduce the mass and build and increase the structural rigidity? Can I increase the power that it can store? Things like that. So these are all diverse properties, but new materials can solve those properties for us. So which means that a heavy amount of characterization studies will be required for new materials. And that is where again you get into physics, again you get into chemistry, mathematics, and so on. Engineering and technology is something that will happen much later. Next, please. So design thinking, integrating arts and humanities. This is something that I said in the beginning. There is also possibility of, why possibility? It's already happening. Integrating humanities and STEM becomes STEAM. So STEAM is when you add A, which stands for arts, is a holistic approach to education and innovation. Recognizes creativity, critical thinking, ethics, communication, and so on. The other is design thinking and creativity. There's actually a very nice method of problem solving, which we don't teach, which we don't even think. Instead of trying to find a problem, instead of trying to find a solution to a problem, why not create problems to a solution? And now you will have multiple ways of addressing the problem itself and finding new solutions. Think about it. Next, please. You have storytelling and communication skills. So storytelling, in fact, the best method of teaching is storytelling. We have several examples, in our ancient studies, and therefore storytelling, it improves the ability to remember, the ability to understand, conceptualize, and so on. Public engagement, ethics, social responsibility. Next, please. Cross-disciplinary collaboration is something that I spoke about. Visualization and data representation also happens because of humanities and arts introduced to STEM. Augmented reality, virtual reality, again enhances the outcomes of AR and VR through art and humanities and communication. Next, please. Critical thinking, analysis, rhetorical analysis, user experience, empathy in AI development, all this is a part of introducing the humanities side to STEM education. Next, please. Again, innovation in cultural heritage, digital humanities, preserving cultural heritage, and so on. STEAM curriculum. In fact, every curriculum development must happen through curriculum maps. So I don't know, you must be aware of curriculum maps. Most of you must be writing course outcomes, program outcomes, and so on. But how do you measure them? And is there a tangible way of measuring those? And that is possible provided you start writing curriculum through curriculum maps. So maybe some other time we'll discuss how a curriculum map is created. Next, please. So innovative startups can happen, social entrepreneurship can happen by integrating arts and humanities in STEM. The entire crowdfunding concept, crowdsourcing concept is because you introduce empathy through humanities into STEM education. Next, please. This is a comparison chart which tells you how STEM and STEAM influence the various technologies in the that we work with. And sometime since you have the presentation, you can take a look at this, and you'll find it very, very revealing. A lot of information you will get in terms of how to develop curriculum itself. Next, please. As far as employment is concerned, 75% of jobs will be in STEM. Not just STEM careers, but STEM will be there in every job. Technology as a global knowledge economy is the future. It requires different skills. And business and industry is already using these skills. That's why we find deficiency, because we don't teach them in the classrooms. STEM jobs in India have been growing with an increase of 44% in the last few years. STEM graduates are considered, to have good employability prospects. There is a gender gap. Women are underrepresented. The national education policy also talks about STEM education, but doesn't tell you how to do it. Then, next please. So careers are highly collaborative. Without collaboration, nothing will happen. Don't be under the impression that I am a good physics teacher, so therefore my job is done. The future doesn't work like that. The fields are always changing. Next, please. STEM graduates, India was a leader in STEM education, contributing 34% of global STEM graduates, way ahead of US. The STEM graduates maximum number of STEM graduates are given by India. At least a few years back. Now there is another country that has overtaken this. STEM workforce, women make up 27%, less than the global average. Percentage of women across fields, the lowest representation in engineering at 15%. So many underprivileged, all that is there. Then bachelors of engineering, bachelors in technology have high employability rate, and so on. So next, please. STEM jobs in India, this is how it looks like currently. In Delhi, 31%, Mumbai, 21%, and so on. So this gives you some idea of, as this was in December 23. Next, please. Now, the next 4 slides, you may look at leisure. What I have done is popular science-based jobs, 10 most popular science-based STEM jobs available in the market is what is, given in this chart. The next, please. This gives 10 most popular technology-based jobs available in the market today. So your curriculum should look at this job availability and modify the content so that you make them more useful for these jobs. Though fundamentally, I believe that universities should not guarantee jobs. They should look at fundamental skills, the basic skills. Next, please. These are 10 most popular engineering jobs available. Next. And popular mathematics jobs that are available. If you are a good mathematics person, These are the jobs that are available to you. Data scientist, high school, main teacher, maths professor, mathematician, OR analyst, and so on, statistician, and so on. Next, please. Now, these are some of the links which I have used to collect all this data. They may be useful to you if you are interested in learning more about STEM. You can visit these links. Next, please. This is the last slide I have. I'm there on social media. You can contact me. I'm there on all the platforms, and there's a Wikipedia page. There's a YouTube channel. You can contact me anytime. Thank you so much. I've finished. If you have questions, we'll answer that. I think you're muted.
Thank you very much, Dr. Mantha, for
Thank you.
such a wonderful overview of all STEM uh, fields and future STEM and jobs, everything together. In fact, that was one of the demands of the participant, which was missing in our course. So, are there any questions or any clarifications needed? If not, let me propose formal vote of thanks. So, first of all, thank you very much, Professor Mantra, for taking out valuable time and coming here to talk to our participants. It was really cherry on the cake.
Thank you. My pleasure.